Hey, if you're new here, my name is Jake, and today we're going to be taking a look at the Codesmith Software Engineering Immersive program. As someone who went through a code boot camp and became a software engineer and has a couple years of experience now, it's kind of interesting for me to come back and look at these curriculums and talk about, what I like about them, maybe some criticisms, and it's just interesting to see what's new and what's popular and what's being taught. I think it's important that the people that are interested in these programs get maybe a third-party review and something about that. But at the same time, I want to be clear that, I don't have personal experience with Codesmith. I've never met the people who run this or spoken to them. I'm purely reacting based on their marketing material. So today we're going to look at the Software Engineering Immersive program. I've got their syllabus. You can get it from their website at codesmith.io. Going to be going over the syllabus, and I've put together a small chart that discusses the things that they teach in their curriculum and things that I like about it, things that I don't like about it. So I've broken this down into 3 categories. We have good, too complicated, and uncommon. So I want to preface this by saying that I'm discussing this from the perspective of the main goal of the person attending the boot camp, which I can't speak for everyone, but I think it is someone that is going to the boot camp to be prepared to get a job as a software engineer or something analogous in the tech world, and they want to have good prospects for getting a job, so a high probability of being hired, and then also be proficient, obviously, at the job, so that when they arrive for their first day, they have the materials and the knowledge and the skills so that they can basically perform at the lowest, at the expected level of a beginner. So that's kind of the lens I'm looking through. I'm not looking through a completionist kind of idea where we need to learn everything we possibly can, or we need to learn for a specific, sort of area like, machine learning or something like that. Very generalist. Let's have a high probability of getting a job, and let's have the skills that we need when we get there to actually perform the duties. So things that go in the good category here would be things that are good to spend time on to achieve those goals. Things that are in the too complicated category are things that are again, they may be really cool to learn and really good for you and something that you'd like to learn in the future. But if we have a limited scope of time to have a high prospect of being hired and achieve that job when you get there, maybe things that are in this category are just a little bit too much to bite off, a little bit too much to get into. So maybe learn them at your own pace or set those things aside. And then finally, uncommon. So things in this category are interesting, certainly necessary to learn depending on where you're at. But, if we were just going to throw something at the wall and see what sticks, I would not choose this as a learning topic. So hopefully these will become more clear as we get into it. So I've taken the weeks and broken them up by colors. So the topics that they cover in each week, I've broken down into their own bubbles, and they're color-coded by week, and then I've set them up. So let's get into this. So in week 1, we're learning data structures, algorithms, time and space complexity, object-oriented programming, and functional programming. Those are the core lectures and subjects covered in week 1 of the Software Engineering Immersive Code Bootcamp. So let's break this down. Why did I put things in where I put them? Obviously, data structures are in the good thing. It's always good to spend time on data structures. It's an essential tool in your toolbox as a software engineer. Additionally, they will be extremely important in your hiring process. Time and space complexity goes right along with that. You basically use time and space complexity to choose data structures and apply them to solve the problem you're trying to solve. So it's important that you understand how these work together, and it's, again, very important in the hiring process. Object-oriented programming is extremely popular. I would say most of the apps you're going to work on as a software engineer will be object-oriented, and if they're not object-oriented, then they would probably be like procedural or something. If I put functional programming, I'll jump down to here. I put functional programming in uncommon, and I mean, some people might argue with this, but it's honestly just not very common. There are specializations in certain areas where it's more common than others, but I don't think I would recommend someone that's learning how to become a software engineer spend time on this until they have a job. And if the job dictates that they need to learn functional programming paradigms, then they can do that. But this doesn't seem important enough to me to put anywhere else other than uncommon. So for too complicated algorithms, I'm going to get a lot of flack for this, but to be clear, what they say here in their syllabus is that algorithms. At Codesmith, residents develop algorithms to solve challenges in software engineering, including pathfinding and searching. So here's the thing: algorithms are important when it comes to your interview questions and things like that. You might have questions that have to do with specific algorithms, but I just don't see them being really relevant when you're first starting out software engineering. I don't think when you start your career, they're going to expect you to write pathfinding algorithms. I think that would be very surprising. I think that those algorithms will probably already be in place. They would have a giant team work on a new one to create it if they needed, or they would use an already existing algorithm. They would not expect you to write one. The algorithms, and people again will probably disagree with me on this, but I think the algorithms that are good to learn are the ones that are directly related to your data structures. So if you're learning, about, maps or arrays, then you want to learn the algorithms that are relevant to those data structures and the time and space complexity of those algorithms. That is certainly always good time spent. But if these are just like pathfinding algorithms or like Dijkstra's algorithm and these like really complex sort of convoluted algorithms, it's interesting and it's fun to learn, but those kind of things will serve you in the interview, and that's about it for your first, So I don't want to spend too much time on this. I know that this is probably going to be a point of contention, but it is what it is. That's what I think. Okay, moving on to week 2. In blue, we have React and front-end fundamentals. So again, another probably interesting point of contention with others that'll say, but what they have written for front-end fundamentals is residents cover front-end design patterns, single-page applications, and features, including model view controller and component-based design, while building their understanding of how DOM manipulation works under the hood. And to that I say, that is unnecessary. Most of your apps are going to be single-page applications, so you should just teach people that right away. They can learn other ways to do things other times. If we have limited time to prepare you for your first job, teach single-page applications. Model view controller and component-based design, that should be included in the teaching of React. I mean, I understand that maybe that's like your basic, like you're setting up to the understanding of React, but you can just smash those two things together. And then finally, understanding how DOM manipulation works under the hood is just unnecessary. And it really pains me to say that because I love JavaScript. I love playing JavaScript and DOM manipulation, but you just don't see it. That's all there is to it. It might be good for you to know. You should eventually learn what it is and how it works, but in a limited span of time to get you prepared for your first job and giving you the skills that you need to actually do the job when you get there, your time would be better spent simply understanding the underlying concepts of React and how DOM manipulation works in the framework of React, as opposed to like the actual DOM API. It's just your time is better spent. So I put that in too nitty-gritty and too complicated. This is unnecessary. Learn the high-level React and spend a lot of time getting good at that. That's just my 2 cents. Okay, so week 3, Redux, Node, and UX. I'm not very skilled with React, so I'm making a lot of assumptions here. But I believe if Redux is indeed the most common state management system for React, then your time will be very well spent understanding how that works. So there's really not much to say there. Node, this was a hard one because it's important to understand how Node works, but in this program, we're facilitating, or our back end is being written in Node and Express. So they have, under the syllabus, it says Node allows developers to create entire applications in a single language. Residents build full stack applications by designing complex backend architecture to connect with front-end logic. We teach Express, a backend framework for Node, to further empower students with what they can create. So yeah, this is tricky for me because on one hand, Node and Express is great to know. I write programs in Node and Express, but and it depends on the company you work at, but it's rare for me to see it in production as a back-end language. I know they're trying to do everything in JavaScript here, but I really would have preferred them using like a static language instead of a dynamic language so that there was some exposure to that. That being said, it's certainly not wasted time. So I can't say it's wasted time to learn Node and Express. It's just not. It's a little weird choice here. I would have picked something else, but I'll leave it in the good category. UX is another one. This really hurt me to put it in the uncommon category, but the truth is that unless you work at a really small company, the UX things that they're talking about here, they say responsiveness, performance, and accessibility are central to creating modern web pages. Residents implement UX best practices to optimize their applications. So building things mobile first for responsiveness is pretty straightforward. If you're using a component library, if you're using a grid library, this should not be very complicated for you. And most of the components and stuff already have performance and accessibility taken into consideration. So as a developer, learning how to build out your UIs with a component library should be really straightforward. It shouldn't take a lot of extra studying for you. And if you want to get into the nitty-gritties of performance and accessibility, which is extremely important, I agree, most companies are going to have a UX person whose specialty is that, or they will go under reviews by companies that do reviews of your front end for accessibility reasons. They'll give you an accessibility rating and they'll give you a guide on how to improve your accessibility and stuff like that. It's the point I'm trying to make is that it's probably rare to expect a software engineer that's just being hired to have any sort of competency in like really nitty-gritty UX stuff. It's probably mostly just expected that you have a basic understanding of component libraries and you use common sense to put together pages so that they work on multiple different viewports, etc. So ultimately, I would not spend very much time on this. I put it in uncommon. Finally, we have week 4 in yellow, SQL authentication MongoDB testing. Another one that's going to be pretty spicy. SQL is the most common database engine. And this coming from someone who loves NoSQL, and I'll say MongoDB, so like document driven, but also key value maps, things like that. Like lots of NoSQL stuff. I love that stuff. It is so cool, and it absolutely has a time and a place to be used. I encourage you to check it out and learn about it. That being said, again, the goals are to get you hireable and have you know what you're doing on the first day. Don't spend time learning about MongoDB. Learn SQL. Become good with it. Understand the Postgres SQL. Understand type ORMs. Understand the basics of it. Spend most of your time on SQL. So that's why MongoDB is in uncommon. If you have time, or if you get interested, please check out NoSQL stuff. You can check out graph databases. There's so much database stuff you can learn, but SQL will serve you the best as far as time and hireability. Okay, so that's my spiel on that. Then here comes another tough one, authentication. Here's the thing, authentication and security is extremely complicated. And again, this is kind of like UX, where there's not always a specialist, but there really should be a specialist when it comes to authentication and security. And there's that saying, never implement your own security. So always use a library, always have something that's like battle tested instead of rolling your own. So I don't really see it, it's kind of interesting to be able to set up your own authentication libraries on your own website. But again, the goals are hireability and knowing what to do on your first days. No one's going to be your first project at work as a software engineer is not going to be implementing an authentication system. It's not going to be, anything to do with security, most likely. So a very cursory understanding of it is really all that's necessary. Ultimately, authentication and security is just too low level to get into in a meaningful sense in a boot camp. And then testing. This is, again, another spicy take. Look, testing is something that everyone loves to hear about in interviews. Oh, like, do you know how to write tests for your code? Do you always write, do you have good test coverage? And the thing is that it's surprising how many companies have missing tests, don't know how to run their tests, or don't have test coverage, or don't even use tests. So as far as understanding how testing works, it's certainly good if you want to look good in interviews, but it's as far as like being useful when you actually get on the job, it's kind of a coin toss how much of this is going to be helpful to you. So, I mean, having, again, a cursory understanding of testing is good, but let me put it this way. It's almost better to learn testing on the job, because once you get there, you get a better understanding of how the organization handles testing, what frameworks they use, their expectations for code coverage, and then you can start ramping up on their testing. As opposed to focusing on this as part of your hireability, I don't really think it's a good use of time. So having some basic setup, just so that if somebody asks you, you can say, yes, I know how to do tests, I have test coverage, I used this library. After that, just there's no more needed. So that's why I put it in uncommon. Okay, and then after that, they have some stuff about projects, scratch and iteration. As far as projects go, people don't look at your resume projects. I'm sorry to say it, but they just don't. What does look really cool is this iteration project. With an aim of adding new features, improving code, and implementing engineering best practices, residents iterate on another group's existing Scratch project. Students get comfortable working with an established code base and develop project management skills. Absolutely. This is going to be the most invaluable project you do. It's not creating your own project. It's not rolling out your own authentication and all this other stuff. It's going to be taking a foreign code base you've never seen before, you have very little experience with, and figuring it out and making a small change. So yeah, these solo projects and these Scratch projects, that's all well and fine, but I would really spend time reading code as opposed to writing code when it comes to this level. Because, that's just the reality of the job. It's a lot of reading code. Okay, and then they have these ideation weeks and open source product kind of creation weeks. I'm not a huge fan of these group projects. I understand that it's sort of like a community outreach sort of thing. So it encourages you to get involved in the community and to contribute, which I think is great. But honestly, a lot of this time could be spent studying, and especially because we're covering so many different topics, all these things that we discussed, it's just a lot. So it would be nice if some more of this was dedicated to studying as opposed to working on projects, because debugging is a great skill, but as you will find out as you work on these projects, most of your time is spent debugging, where it can turn into a black hole really quickly if you don't have someone there that is knowledgeable to lift you out of your debugging black hole. You're just going to waste a lot of time, and who knows if there's enough teacher resources to handle all those requests. So that's one thing I worry about. And then they have additional lectures that are available for students to take, it looks like, which is awesome. So I would highly recommend attending some of these. Security, DevOps is really interesting, but again, for hireability and knowing what you need to know for the first days, I wouldn't bother. System design, let's see. You're probably not going to get asked system design questions in your first software engineering interview. That's kind of a higher level thing. Design patterns, that would be good. Design patterns are always helpful. Often very overlooked. Probably wouldn't be asked in interview questions, but design patterns would be super helpful when you actually get on the job to understand. Because, again, we talk about reading code. If you don't understand the design patterns, none of the code will make sense. Resume development is good. Interview prep, great. Networking day, I could take it or leave it. Machine learning, unless you're really obsessed with machine learning, I wouldn't bother. Even then, most machine learning and data analysis jobs are quite specialized. You would have wanted to come into this program laser focused on those kind of things. This isn't kind of like a blasé, you can kind of pick it up with this class sort of thing. And then they have some post-graduation support, which is awesome. Okay, I don't want to dwell on this too long, so I'm just going to leave it at that. If I had any final words, I would say, take everything I said with a grain of salt. But if you can keep your focus in this top layer of good topics, and kind of just spend a little bit less time on maybe the too complicated or uncommon things, I think that you're going to get a better understanding of subjects that will be of great use to you as a beginning software engineer. And then you maybe won't spend as much time on subjects that may not help you in the very beginning of your career. And again, I want to reiterate that just because something's too complicated from my perspective or uncommon, I'm not saying that you should never learn about that. I'm simply saying that from the perspective of someone wanting to get hired and do well in their first position, maybe it's not a topic to get too absorbed into. Just my thought process. But yeah, that's it. Thanks for watching, everybody.